Right. Hello, everyone. So this is going to be the second, going over the second part of the notes here that I didn't cover yesterday for the nature of chemical reactions note. Okay, and that's I had skipped forward over the writing chemical equation stuff just to go right to the balancing. So today we're going to cover the writing chemical equation portion of this. So a chemical equation, as it says here, is a word or formula equation showing both the reactants and the products of a chemical reaction. The reactants are always on the left side, and the products are always on the right side. Okay, so we have an example here. The top one would be, this one would be a word equation. Okay, and then this one would be a formula or molecular equation. Okay. Now, see the things in parentheses after? Uh, these are these represent states of matter. So, okay, it can be kind of confusing. Up here in the reactants and products, that means like plural. Like in other words, you can have one reactant or you can have multiple reactants. You can have one product or multiple products, depending on the thing. Down here in the actual equations, these things in parentheses are the states of matter. Okay, so we have S, solid, L, liquid, G is a gas or vapor. And then there's one which is AQ, and this is aqueous. Aqueous isn't a state of matter. It just means like a solid thing dissolved in a liquid in a solvent. Um, but it's used sometimes. Okay, now we're not going to really worry too much about these in Chem 1. States of matter are important when you start doing like thermodynamics, like the energy exchanges and stuff, because certain states of matter for the same substance would contain more or less energy. I just want you to know if you ever see those in an equation, what those are referring to like that. Okay, so like this is saying solid calcium plus oxygen gas would produce solid calcium oxide. That's what that's saying. Okay. I'm not going to have you guys worried about those really in Chem 1. I just want you to know if you see them to understand what they are. Okay. All right. When writing formula equations from word equations, so when going from the word to the formula, or from a paragraph format, here are some helpful hints. Okay, A. Words such as and, reacts with, combines with, stuff like that, usually indicate separate substances on the same side of the reaction that need to be separated with a plus sign. Okay, so things like those usually refer to the fact that you need to separate those substances. They're on the same side of the equation, but you separate them with a plus sign. Okay. Words such as produces, to produce, decomposes, creates, to form, stuff like that, usually indicate the occurrence of a reaction, which is indicated by a yield symbol placed between the reactants and the products. So produces, to produce, decomposes, creates, to form, things like that are the indicator that like it's actually talking about the reaction happening. Okay, which is where you would put the yield symbol. Okay. All right. Then there's one other important thing when doing chemical equations, especially from words or whatever. And well, not just those, but that matters as well. There's these things called diatomics. Okay. Diatomics are elements found in pairs in nature. Okay. This is only when they are alone In other words, just the element, not as part of another compound. When they are alone by themselves in these chemical reaction equations, they are what are called diatomics. Di meaning two, atomics referring to atoms. So these seven, only when they're alone in an equation, when they're by themselves, they are found in pairs. Okay. I write it this way because I call the diatomics Hofbrinkel. You'll hear me say it a billion times from here on out. I usually say, don't forget your Hofbrinkel. That just comes from making a word out of all of them, like Hofbrincl, Hofbrinkel. It's just the way I remember them, but you have to memorize them. Okay, there are seven of them. And the more work we do on it, the easier it'll get. You'll remember it, but you'll probably get sick of me saying, don't forget your Hofbrinkel. There are seven. These seven elements, when they are alone, they're in pairs. So H, O, F, Br, bromine, I, N, and Cl. Those seven, when they are alone, they're in pairs. Okay, any other elements, when they're alone, are just themselves. Okay, all right. Let's take a look at, we're going to take a look at a couple of examples from the homework that you guys have. So this word equations homework here, you're going to write the equations and balance them. Okay, I'm going to do it on a sheet so I can upload this so you guys can see it when I'm done here. But okay, so I'm going to do numbers 1 and 6 off this worksheet. So zinc plus lead-2 nitrate yields zinc nitrate plus lead. So we need to turn this into a formula equation. Okay, so zinc, just zinc by itself, nothing else, nothing to combine it with. So zinc is Zn. Okay, so I'm gonna leave a little space here to show my like making the equation or whatever. So I'm going to do zinc. Okay, zinc is just Zn plus, that's going to separate different substances, lead to nitrate. So we've got to make this. So lead is Pb, and if we were to look on our periodic table, we don't know what lead's charge is. It's one of the ones with the X. So that's what the Roman numeral tells us. Pb is a +2. Nitrate, ending in 8, so that's off of our polyatomic sheet. Nitrate is, where is it? Right here, NO3 -1. These are, it's an ionic, so let's just see how we can reduce. Can't, we cross down. So lead-2 nitrate is going to be, and notice I'm going to leave space for my balancing. So lead-2 nitrate is going to be Pb, parenthesis, NO3, parenthesis, 2. Okay. Yields, that's my arrow. It's like an equal sign, sort of. Yields. Zinc nitrate. So we're going to do the same thing we did over here. So zinc, Zn, our periodic table tells us that zinc is a +2. Okay. Nitrate, we already know, NO3 -1. We cross down, right, and we get, leaving some space for coefficients for balancing, we get Zn, parenthesis, NO3, parenthesis, 2, plus lead, plus Pb. Okay? All right. Now, I can already look at this and I actually know that it's already balanced. I'll show you guys just so you know, but this one actually is already balanced. So we've got Zn Pb, N, and O. Okay, so on the left side, we've got 1 zinc. I've got 1 Pb. Now, the 2 goes to both of these, so it's times, 2 times 1, so I've got 2 nitrogens, and 2 times 3 is 6 oxygens. Okay, over here, I've got 1 zinc. Now, remember, the 2 only goes to the stuff in the parentheses, so 1 zinc, Pb lead, I've got 1. Nitrogen, 2 times 1, 2. Oxygen, 2 times 3, 6. And if we look, 1, 1, 1, 1, 2, 2, 6, 6, we're balanced. So I don't actually need to put any coefficients on this one. This is the answer. All right. All right. Excuse me. I'm going to skip to number 6. So here, number 6. Okay. It's right here. Now, in my writing, I didn't have enough to go all the way across, so I've got it in 2 levels here. So, okay, calcium hydroxide. So calcium, I look on the periodic table, calcium is a +2. Hydroxide is off of here. Okay, hydroxide is right here. Oh, sorry. Hydroxide is right here, OH -1. Okay, now that's a polyatomic because I've got 2 capital letters, right? So I need to, if I cross down, in doing that though, I end up with Ca, and then I need parentheses around the OH. Okay, even though there's not a number down here, that's still, there's 2 capital letters, so I want the 2 to go to both of them. I want to say we have 2 of this whole thing. So it should look like that. Okay, plus phosphoric acid. Okay, now this is an acid one, so that means all acids are going to start with hydrogen, right? H plus 1. There is no hydro. That tells me that I want the thing that gave me phosphoric, but instead of it could be H, so it'd be phosphate. Right, so I look on here, phosphate, PO4 -3. It's polyatomic because there's no hydro. So it's PO4 -3. I cross down, and I end up with, I'm leaving space for coefficients again for my balancing, H3PO4. Okay, calcium hydroxide plus phosphoric acid yields my arrow. Calcium phosphate. Okay, now I've already got all the charges here, so I don't have to go back and look stuff up. Calcium I know is a +2. Phosphate I know is PO4 -3. Cannot reduce, I cross down. So this gets me, leave a little space for my coefficient in case I need it. Ca3 parenthesis, PO4 parenthesis, and then the 2 on the outside. Okay. Plus water. Okay, now you could do the whole combining the H plus and the OH, but we know water is H2O. All right. Balancing. Okay, let me slide this up a little bit here. Okay, I'm going to do a T-chart here. So okay, I've got calcium, oxygen, hydrogen, phosphorus. Okay, so same thing over here. Calcium, oxygen, hydrogen, and phosphorus. Okay, so let's look over on the left side on the reactants first. Calcium, I've only got one calcium. Remember, the 2 only goes to the stuff in the parentheses, so I got 1 calcium. Okay, oxygens. I've got here 2 times 1, so I've got 2 oxygens here. Over here, I've got 4. So you add those. So 2 and 4 gives me 6 oxygens. Okay. Hydrogens. Here I've got 2 times 1, so 2 hydrogens. And over here I've got 3 hydrogens, so it's 2 plus 3 is 5. Phosphorus. Okay, phosphorus over here. Now, notice the 4 is on the oxygen. It's not outside of parentheses, so it just goes to the oxygen. So phosphorus here, we just have 1. All right, let's look on the right side. Okay, calcium. We've got 3 calciums. Okay, oxygens. So here I've got 2 times 4. I've got 8 oxygen, plus I've just got 1 here, so that's 9. Hydrogens. I've only got hydrogens right here, so that's 2. And phosphorus. Now over here, see how the 2 is on the outside of the parentheses? So the 2 times everything inside of it, so 2 times 1, meaning I've got 2 phosphorus. All right, this is what I'm starting off with. Now, I gave you a clue on the balancing when we were doing it yesterday. I said, do balance the elements in order from the fewest spots they're in to the most. So, like calcium is in 2 spots. Oxygen is in 1, 2, 3, 4. Hydrogen is in 1, 2, 3. And phosphorus is in 1, 2. So I would balance calcium and phosphorus first. Then I would do hydrogen because that's in 3 spots. And then I would do oxygen last because that's in 4. Okay, hopefully that'll help me balance it more easily. So calcium, I've got 1 and 3. So I need 3 over here. So I'm going to put a 3 in front of calcium. So this gives me 3 times 1, 3 calcium. Okay. And it also gives me, now we got some math to do here. So 3 times 2 times 1 for the oxygens. So 3 times 2 is 6. 6 times 1 is 6 oxygen just here. And then we've got 4 over here. So 6 plus 4 gives me 10. Okay. Now, next we have our hydrogens. 3 times 2 times 1 is 6, plus the 3 here. 6 plus 3 means we're at 9. Okay, and it didn't affect the phosphorus. All right, so let's check now. So we're going to balance calcium and phosphorus first. So we've got calcium balanced, 3 and 3. Phosphorus is not balanced. We got 1 on the left, 2 on the right. So we need to get 2 over here. How do we do that? Well, we've only got 1, so we put a 2 in front of this. 2 times 1 gives me 2 phosphorus. All right, now let's see what that does to the rest of the stuff here. So that's going to affect our hydrogens, right? So we've got 2 times 3, 6 hydrogens here. Okay, and we've got 3 times 2 times 1, 6 hydrogens here. So 6 plus 6 takes our hydrogens to 12. Okay. Oxygens. 2 times 4 is 8. 3 times 2 times 1 is 6. 6 plus 8 is giving me, what is that, 14 oxygens. All right, so this is where we're at now. Now, if we've looked, our calciums are balanced, our phosphorus is balanced. So the next fewest was hydrogen. That was in 3 spots. So let's go to our hydrogen and take a look. We've got 12 over here. We've got 2 over here. So let's see, can we get 12 on this right side? Yes, we can. This is 2, so 2 times what? So we're going to put a 6 in front as a coefficient. 6 times 2 now gives me 12 hydrogen. Okay, now let's see what that does to my oxygen. 6 times 1, I've got 6 oxygen here. Over here, we've got 2 times 4 is 8. 8 plus 6 is going to get me 14 oxygens total. Okay, now, if you've looked, we've got calcium balance, phosphorus balance, hydrogen balance, and actually doing the hydrogens balanced our oxygen. So we are now balanced. So this is the balanced equation. 3 Ca parenthesis OH parenthesis 2 plus 2 H3PO4 yields Ca3 parenthesis PO4 parenthesis 2 plus 6 H2O. Totally done, balanced, and we're good. Okay. So hopefully that helps you a little. If you guys run across anything else, a couple of things just to mention at the very end here. The number 4, the one heated, that doesn't do anything. You can literally just ignore that. Potassium chlorate yields potassium chloride and oxygen gas. Okay, the when heated part is just what triggers the reaction, but it's not part of the actual like written equation. Okay, and then down here, and number 7 and 8, just be careful. Like sulfur dioxide and nitrogen monoxide, those are covalent molecular in terms of how they're written. So remember, when it's like they've got the mono di-tri stuff in them, you don't use no charges, no crossing. Prefixes tell you how many there are. Okay. All right. If you guys have questions, let me know. I think that's, don't forget about your Hofbrinkel on these. So for example, aluminum bromide plus chlorine. Chlorine, when you put it in, because it's alone, is going to be Cl2. Bromine, when you put it in, because it's alone here, is going to be Br2. But when you make the formulas here, these are not alone, so you have to do the charges and the crossing. Okay. All right. Hopefully that gets you guys pretty far on that. If you guys have questions, let me know. Good luck.